Ready? Organic people, take the headphones out. I'm going to give you guys some notes just to kind of explain what you've been looking at so far. Hopefully things will now make a little bit more sense. I'm hoping, again, with that pre-learning, it helps with that working memory. So this should hopefully be a little bit easier. Cool. So what I want to show you guys for today, so we did some notes on structural isomers yesterday. You guys have been working through some of the SciPad pages. I want to show you guys how the material you're doing right now is going to be used in an exam question, just so you can see where we're working towards and how you can apply what you're already learning. So, as always, I pick from the past exams so you guys can see exactly how it's being used. I do want to give you guys a heads up that I did upload the questions onto Google Docs if you want to write your notes on the Google Doc. It is there. So if you want to do that while I'm talking, you're more than welcome to. Otherwise, you're welcome to also write it on a piece of paper like I am. I didn't print out the question because, again, I don't feel like it's necessary, and I feel like it's a waste of paper because a lot of the stuff isn't like super critical to be printed out. I think that's more or less it. Cool. So we are looking at the 2023 exam. So this is the exam from last year, and I want to look at question number 3 with you guys. As it keeps loading. All right, what should I want? I wanted this one. Nope. This one. Nope. This one. Took me a while. No, I found it. Okay. So this is talking about structural isomers, which is something that you've been covering in your current kind of topic. We did talk about this yesterday. Structural isomers are molecules that have the exact same formula, but different arrangement and different bonding patterns. So it's just a matter of breaking the bonds and rearranging how all the atoms are organized. Is that okay with everyone? All right. What they've done for me is they have given me a formula, and they want me to draw 4 different isomers to it and refer to their names and also explain why they are structural isomers. So, let me write down the formula, which is C4H10O. And they've given us the first one, which is butane 1-ol. All right. So some things I just want to point out to you guys so you're aware about it. This is useful for level 3 chemistry, so it's a little bit advanced, but you guys are already advanced. We're doing level 2 chemistry and level 1. Something to always check is the ratios between the carbons and the hydrogens, because that gives you a lot of hints to what you're dealing with a molecule. Basically, what it can tell you is whether or not there's a double bond present, so an alkene. So we are looking at basically the number of carbon versus the number of hydrogen. And what we are thinking about is it a multiple of 2 plus 2? So we're looking at it times 2 plus 2 for the numbers. So if I do 4 times 2, I have 8, plus 2 is 10. So what that tells me is that there are no double bonds. This is all single bonds. It's a really useful hint to know. We okay with that? All right, they have given me 1 molecule so far, and that was my straight chain alcohol with the alcohol on carbon number 1. So actually, I'll keep it the pink. So they gave me 1, 2, 3, 4 alcohol on carbon number 1, CH3, CH2, CH2, CH2. And then when I do the math, these guys add up to the formula over here. 1, 2, 3, 4, 4, 1 oxygen, 10 hydrogens, 3, 5, 7, 9, 10. Cool? So that's what we need to be making sure that we're keeping along with. And they've given me the name. They said this one is butane 1-ol. So just to kind of recap some of the stuff that you've been learning, this is the length of the carbon chain, tells me it's 4. This tells me the functional group, which is an alcohol. Alcohols are the OL ending. They can also go in the front as a hydroxyl, is another way to do it, as a prefix. And then 1 tells me where it's located. All right. When it comes to isomers of this situation, what I would do is I would move the functional group first and see how many variations I can get with that. So we take this alcohol over and we move it down to the next carbon because that will help me form a new type of molecule. So in that case, it would be 1, 2, 3, 4. Alcohol is now on carbon number 2. You have to name them for this question. If you're doing any isomer question, I would suggest naming it because it's a really good way to make sure you don't accidentally make 2 of the same things. So now this has basically changed this number from a 1 to a 2. Are we okay with that? Just checking in on you organic people. All right. So next thing I then do is I want to see, okay, if I move this OH down again, do I make a new molecule? Do I? No, because it's still butane 2-ol because I would start numbering it from this way. If I move this onto that carbon, is it a new molecule? No, because now it's butane 1-ol again. So I have done moving the organic molecule. Now what I want to do is I want to start moving my my carbon chains around so I can then start naming them differently. So I'm now starting to look at how do I move either one, this guy, how you want to do it as a reference. Let's move it on this guy. We'll keep alcohol on carbon number 1 and we'll make a 3-carbon chain. If I was to move this guy, where's the only way I can move it? That one. Can't put it here, can't put it here because that's N carbons now. So let's do that. 1, 2, 3, moving that methyl onto carbon number 2. And let's have the alcohol on carbon number 1. We'll just keep it there for the time being. And let's put in our hydrogens. That's CH3, that's CH, that's CH2. When in doubt, just do some counting. We have 1, 2, 3, 4 carbons. We have 1 oxygen, still matching the formula up here. And then we have 3 and 3, that's 6, 7, 8, 9, 10. 10 hydrogens still. So we still have the exact same formulas. All right, last thing, there's still one more. Oh, sorry, I haven't named this guy yet. So naming wise, we start numbering here because even though you have a branch and you have an alcohol, the preference goes to giving the alcohol, the functional group, the lower number. So you have to be mindful that there's all these layers to the rules, and then once something new gets added, it gets the higher preference. So in this case, we're not as worried as the number we give the methyl because the alcohol is more important, so that's going to determine that this is carbon 1. So 1, 2, 3, I now have propan. And then we're having it on carbon number 1, all, and then I need to name my methyl. My methyl is on carbon number 2. So 2-methyl. Cool. There's still one more molecule you can make because in that box it had 1, 2, 3, 4. The 4th one now, we're going to move that alcohol onto the 2nd carbon so they're both branching off the center. So 1, 2, 3. OH goes here. CH3 goes here. And then we fill in our hydrogens again. Let me just make that look like it's not as messy. There you go. And then all I changed in the naming is it's still 2-methyl, but now it's propan 2-ol. Just drop my pen. Questions, concerns, comments? It's all just a process. So don't rush it. Start with a technique. Start with the straight chain. Start with the function group at the end. Move the function group until you can no longer move it. Then start moving your carbons around. So that way you don't accidentally miss somebody. Something I want to point out that you're probably going to start seeing in your books, because I'm pretty sure I did assign those pages, and it does come up as a question on the exam, is they want you to identify these guys as primary, secondary, or tertiary. So let me explain what that means. When they're talking about primary, secondary, or tertiary, they're often talking about things like alcohols, haloalkanes, or amines. And they're basically just referencing where is the alcohol attached to in reference to the carbons. So what you're looking at is here's my alcohol. This is the carbon it is attached to, and I want to see how many neighboring carbons are attached to it. So this carbon here, I look over here, it only has one carbon attached to it. So that is known as a primary alcohol. Let me show you the others, and then we can backtrack. This alcohol over here, I check the carbon that it's attached to, and I check to see how many carbons are attached to that carbon. That's 2, so that's a secondary. This one over here, this alcohol is attached to that carbon. Go over, see how many carbons it's attached to. It's only attached to 1, so this one's also a primary. And then this guy over here, that's my alcohol, that's my carbon. 1, 2, 3, tertiary. I love that smile when you like understand it, isn't it great? The same thing happens with the haloalkanes. So it's the same naming pattern. All right. So when they ask you a question, they often ask you like, can you draw a primary and a secondary version of the alcohol? It comes up. Are we okay so far? All right, let me show you guys the marking schedule. There is this little bit here that asks you to draw them all and explain why they're structural isomers. So all of these are structural isomers of each other because they have the same molecular formula, which is C4H10O. The only thing that makes them different is how are they bonded. So let me pull up the marking schedule just so we can see everything that we need and make sure I don't forget something. We're on question number 3. It's that one. Let me zoom up. Where is the zooming? Oh, that's fine. You know why I can't see it? It's because I'm covering it. There you go. Okay, so those are our 1, 2, 3, 4 answers, and you see the naming. In fact, you don't have to specify that the methyl is on carbon number 2 because that's the only place the methyl can be. Does that make sense? You won't get penalized if you do label it, but you don't actually have to. So, because if this methyl was on carbon 1 or carbon 3, it's now propane. Okay? So you don't need to label the methyl. If you do, you're not going to be penalized for it. So here's the justification. These molecules are structural isomers because they share the same molecular formula, but their atoms are arranged, bonded, or they have different structural formulas. That's all they're looking for that justification. This question only went up to the merit level, FYI. Achieved was drawing 2 isomers correctly. You don't have to name them. Or drawing 1 isomer correctly with the name. So that's not too bad for for achieved point. The other thing for the achieved is defining structural isomers. So just saying structural isomers have the same molecular formula. So this here would be the achieved statement. Tying it back to the question is the merit point. So you see how they mentioned the formula? That's what's getting you the merit point. All right. Be careful. That's a common thing in a lot of science exams is referring it back to the question. So there's lots of general knowledge you guys have, but you need to apply it to the question that's being presented to you. So tie it back to the molecules they've given you. Don't just, you can talk generally, which is structural isomers have the same molecular formula, but tying it back to the question, be like, these are all structural isomers of each other because they all share the C4H10O formula. Okay? Questions, concerns, or comments? All right. Keep working on that. Do try to work ahead to the alkene stuff. So just be mindful that Tuesday is the last day that I want us to work on this. So do some homework. These pages here are the SciPad pages for the alkanes. Do that pre-learning. I will go over the notes. I will show you another exam question, and then I want a no brain too small. Sorry, not no brain too small. You should do some no brain too small questions. These show you guys all the collated versions of that, so you can just see the different ways they ask it. So here you go. This is an example. They have an alcohol drawn here, and they ask classified as primary, secondary, or tertiary. Explain your choice. So that's why I explained that to you guys today. Cool. I do also have a CPR quiz. You guys are welcome to start doing it because the first question on there is on alcohols. Not alcohols, on structural isomers. So if you want, you can do half of the CPR quiz. This half we'll do next week. Okay? Cool. Make sure you're working outside of class because we got to keep moving.